Hi, welcome to my channel, JaberTime. This video is about logarithmic properties, and I do have enough examples. Writing the examples as I go while I'm recording will take a lot of time. So this is my style. I write all my notes ahead of time so I could save you some time from the recording and expose you to more examples. Let's get started. Logarithmic properties. The first property is called the product rule for logarithms. Log mn as a product, m times n, equals the sum of log m and log n. So it's kind of like, and now I have two logs, one for m and one for n, with the sum in between. These powers or power rules or logarithmic properties are not really hard. Just like kind of like straightforward. You just need some practice and you'll be fine. Here's an example. Log 30x multiplied by 3x plus 4. To use the product rule, I could think about 30x as the product of 2 times 3 times 5 times x. 2 times 3 is 6. 6 times 5 is 30. So having this as a product, I'm showing you that with adding the dots in between. We're going to apply this rule and we're going to end up with log 2 plus log 3 plus log 5 plus log x plus log 3x plus 4. Same base, as you could see, all over the place. We're done unboxing my answer. We're done. Here's something that some students might make a mistake with. This part right here cannot be expanded more. Log 3x plus 4 does not equal to log 3x plus log 4. That is not a product rule. This is product becomes a sum of two logs. This is not a product. So I can't apply this rule. Just keep that in mind. Here's the second rule. Second rule says the power rule for logarithms. It says log m to the power n base p. It's kind of like the way it says it. I'm gonna pull the n all the way up front. As you can see, no more n being on top of m inside. Let's see how we could apply it. Log 8x base p. I could think about 8x as 2 to the third x. So I could use the power rule, right? 8 is 2 to the third. We know that, right? 2 times 2 times 2. I'm going to use the product rule. Then I'm going to use the power rule. Using or applying the power rule, that becomes log 2 to the third plus log x. Now I'm going to apply the power rule and take n up front. In this case, take 3 up front. And that should do it. We're done. As you can see, unboxing it, we're done. As you can see, I'm trying to go a little bit fast because it's not really complicated and I'm having enough examples for you. So writing the notes ahead of time will save me and you the time. Let's try it in a different way. Log 8x base p, I could think about it as 8 equals 2 times 2 times 2. Now I'm not using the power, I'm using the product. Applying the product, that becomes log 2 plus log 2 plus log 2 plus log x. But that's kind of like the same amount 3 times, which is in math, we call it 3 times log 2 plus log x. And if you see it left and right, it's the same answer. And that's the power of math. As long as you're using rules correctly, you should get the same answer. If there is no mistake in your steps, you should get the same answer. Let's move on to more examples. Here's an example done in 2 different ways. You could see ahead of time that I'm dividing the slide into 2 parts with the same problem. On the left, log x to the second. If you think about x to the second as a product, which is x times x, I could apply the product rule and make it 2 logs. Log x plus log x base p is same base. which simplifies to 2 log x, because you're kind of like saying apple plus apple, 2 apples, combining them. Let's go the other way around using the power, not the product. Well, if you think about this as a product, as a power, sorry, I'm gonna pull the 2 up front. So I have 2 log x. Sorry, gotta turn this slide off. 2 log x base b. Same answer as you could see. Let's move on. Logarithmic properties. The quotient rule for logarithms. If you have log m over n, I could distribute the logs, if you call it that way. I have 2 logs, but in between it's not going to be addition like the product rule, it's going to be subtraction. Let's apply it. As you can see, those are lengthy examples, and imagine if I record and I write as I go with the stylus and a tablet. That's going to take too much time from me and you guys. So that's my style. One more time, I try as much as I can to save you some time and give you more examples. Let's do it. Now we have a quotient right here, so I'm gonna apply the quotient rule as it shows right here. Log m, if I refer to this as m and n, this is like my m and this is like my n, so I'm gonna apply it. Then on the left, I'm gonna use the product rule, and on the right side here, I'm gonna use also the product rule. To do that, I'm gonna think about 15x as 3 times 5 times x. Log 3 plus log 5 plus log x plus log x minus 1. Here, it's like 3x plus 4 plus log 2 minus x. Just be careful with the minus sign. That's why I'm using brackets. And this minus sign is for this whole thing, right? So we gotta be careful. Let's distribute the minus sign, and we're done. That's it. So when I box it this way, that tells you that we are done. Let's move on to another example. Some examples will go quick. There is no need to slow down, and hopefully I'm not going too fast. Expand ln x to the second. I could pull the 2 up front as a power rule, and we are done. Take a look. 2 ln x. We're done. Take another example. How do you expand log 25? Well, I could think about 25 as 5 times 5, use the product rule, or 5 to the second and use the power rule. Here we go. Let's use the power rule. Put the 2 up front, 2 log 5, and we're done. One more example. Ln 1 over x to the second. I could think about 1 over x to the second as x to the power negative 2. The reason is 1 over x to the second is equal to x to the power negative 2. Those are properties of powers in math. Once I do that, I could pull the minus 2 up front, and we're done. Let's do it in a different way. Let's think about the quotient rule. How do you expand this using the quotient rule? I'm going to go ln 1 minus ln x to the second. That's like my m, and this is like my n. But what is ln 1? Ln 1 is 0. 0 minus 2 ln x simplifies to minus 2 ln x. Same answer. To support this part, here's a graph showing you that the log or ln goes through 1, 0, ln 1 equals 0. That should do it for this problem. Let's try another one. This has a product on top, and the whole package is a quotient. So we're going to apply the quotient rule first. Becomes log 6x minus log y, same base, b. We're going to apply the product rule right here and make it log 6 plus log x minus log y, and we are done again. Here's another one. Log a over c, quotient rule, or I could play around and change c to the power negative 1. Then I could use the product rule. Then I'll use the power rule. Here we go. A over c is the same thing as a times c to the power negative 1. If you move the c to the top, it has to change to a negative exponent because it was a positive exponent down below. Applying the product rule, it's log a plus log c to the power negative 1. Applying the power rule, I'm going to take the minus 1 up front, change this to a subtraction. There's no need to say plus negative 1 times, and we're done. Let's take another example. As you can see, I have a lot of examples, but they do help. I'll put timestamps in the video, so in case if you want to revisit the video or you want to watch something under the title, you could skip and go to it with the timestamps. You don't have to watch the whole video. Rewrite ln x to the power 4y over 7 as a sum or difference of logs. That's another way to say it, like expand this whole thing. And to do it, I'm going to think about the quotient. So I'm going to say log x to the 4y minus, that's the quotient rule, ln 7. I don't know if I said log, it's the same thing. Ln x to the power 4y minus ln 7. This is a product, so I'm going to split that and say ln plus ln, as you can see. Then I'm going to take the 4 up front and apply the power rule, and we're done. Let's take another example. Log square root of x. How can I use the power rule here? Because I don't have a product or a quotient, so I'm thinking power rule. Well, square root of x could be written as x to the power half. Then I could take the half up front, and I'm done. Let's take one that has cubic root and even more into it, like x to the second. Well, I need to see this as a power. All what I need to see is I could see it x to the 2 to the power 1/3 or x to the power 2/3. To make it clear that I want to take this up front, I'll rewrite it this way. Then I take 2/3 up front, and we're done. I keep saying we're done because I have too many examples, as you could see. One more time, hopefully I'm not going too fast because I don't want to make the video like 45 minutes or an hour. Let's keep going. Using the power rule in reverse, how do you take it back? Expanding makes it longer. I want to take it back now. I'll start with a simple, quick example. Rewrite 4 ln x using the power rule for logs to a single logarithm with a leading coefficient 1, not 4. Here the leading coefficient is 4, but we want it to be 1. What do? Take the 4 back in, just like that, and we're done. The leading coefficient 1 is not 4 anymore. We're done. As simple as that. Now, not all the examples are so quick, but this is the first one. Let's see another example. Sometimes instead of calling in reverse or a single, we say condense. Condensing logarithmic expressions using the product and quotient rules to combine logarithms and make it one log. Here's an example. Rewrite or write log 5 plus log 8 minus log 2, all base 3 of course, same base, as a single logarithm. That's called condensing. Well, the first part is a sum. That means it came from the product rule. As you can see, I'm writing 5 times 8. And 5 times 8 is 40. I could simplify. Then the subtract here, I could take it back to a quotient rule. Becomes log 40 over 2. And 40 over 2 simplifies to 20. And we're done. I'm saying it again. We're done. Take another example. This has more into it, but nothing is hard, as you could see. Let's try it again. How do you condense it? How do you make it one log? We're gonna, before we start, take the half back in and take the 3 back in. Alright, here we go. I'm taking the half in, as you could see right there. I'm taking the 3 up there, and that's why we have another set of parentheses ready for the 3 to come back in. This is a sum, so I'm gonna use the product rule. Before that, we change this to square root because to the power half means square root. Now let's apply the product rule. 1 log and a product of m and n, if this is called n and this is called m. This is a subtract, so we're going to apply backwards the quotient rule, and we're done. One more. It looks like the 4 is in my way, but we'll keep the 4 till the end. Let's work inside. I think I want to take the 3 back in. So let's do that. Here's the 3 back in. Let's change this addition back to a product. You see it right there? Let's take this subtraction back to a quotient. Let's take the 4 back in. Done. Imagine if I do this problem with you guys and I'm writing step by step. Takes a long time. So I prefer this method to help me and help you and make it quick. I think this is the last topic of this video, which is the change of base formula. And this is how it goes. It can be used to evaluate a logarithm with any base. I have an introduction to it, then I will finalize it with a good example for you to practice. Here we go. For any positive numbers m and b and n, where n does not equal to 1 and b does not equal to 1, the log m base b becomes log m over log b. Look at n right there. That was not mentioned. Base n, same base. You pick on any n, as long as you keep it the same, you'll be fine. You could pick n as 10. You could pick n as e. If you pick n as e, that becomes a natural log, len m over len b. So it doesn't matter. This is a special case of this. As I said, to get you started and understand the change of base formula, I'm going to start with basic examples that we could believe in and we understand the answers and believe in it before we start using a calculator. We know that log 10 base 10 is 1 because that's supposed to be base 10, right? If it's not written, it's a common log agreed on to be base 10. 10 to the power 1 is 10. That's true. How about 100? 10 to the power 2 is 100. That's true. How about in between? Something like log 50. Well, if this is giving me 1 and this is giving me 2, that should give me something in between 1 and 2, right? This is what I mean. Like, it's good to know and practice and understand your numbers. See if it makes sense when you use a calculator. That's called number sense. If the number is out of what you should expect, you should investigate, either reject or test your steps again. Here we go. Log 50. It's base 10, of course. You could use a calculator, and if you use the calculator straightforward, we're not practicing. I just want to let you know that the number should be between 1 and 2, and it comes up to be approximate to 1.69897. If you pretend you want to practice the change of base formula, this is the change of base formula. So I'm going to think that this is my m and this is my n, or what was it? M and B. This is my m and this is my b. I want to bring a new n as a base n. So that's n and n. That is different color. That's my n. I could use that. I'm just applying the formula right there. Well, like 50 base 10 on the calculator could be handled because calculators do have base 10 keys. And like 10 over base 10 is known to be 1, which is right there. You could use a calculator to double check. It ends up like 50 base 10 over 1, which is just exactly what agrees with our problem. It's the same thing. So I'm kind of like trying to speak this formula just to get used to it. It doesn't contradict. I know I'm not going anywhere. I'm not using a calculator, but let's take a look. Log 9 base 10, 10 to the power, what is 9? That's a question. I could use a calculator because the calculator does have a key with base 10. Since log 10 base 10 is 1, we know that, and log x base 10 is an increasing function, when you look for log 9, it should be a little bit lower than 1. Using the calculator, I have 0.95, which makes sense. Using the change of base formula, you can double check with the change of base formula to practice using it. Log 9 base 10 is len 9, I'm using len now, over len 10. Use a calculator. Test it. Type len 9 over len 10. If you get something lower than 1, like 0.95, that means you're using the formula correctly and you're using the calculator correctly. Here's another example, a good one. How about log 8 base 2? 2 to the power what equals 8? Well, we know the answer. If you think about 2 to the power y equals 8 in exponential form, and we know that 2 to the power 3 equals 8, that means the answer is 3. So the calculator does not have base 2 logs, but with the change of base formula, you could use a calculator, and if the calculator gives you 3, that means you're using the formula correctly and you're using the calculator correctly. That's my advice to you. That's why I'm picking numbers out. We should expect those answers from the calculator. Using the change of base formula, log 8 base 2 becomes log 8 base 10, log 2 base 10, or len 8 over len 2. Try it. Take my advice on your calculator, and if you get 3, that means you're using the formula correctly and you know how to use a calculator correctly for this type of math. And that should do it. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.